Okay, so we're going to talk about dividing and multiplying functions. So we've done this before, we just haven't called them functions. So we have our f of x and we have our g of x. And so if we look at the first example, we're going to go ahead and multiply. And so the terminology, you have f times g of x, and all that's saying is take your two equations, and notice that's a filled-in circle. An open circle is something different that we'll get into. We just multiply the two equations together. So for multiplication, all we're doing is we're taking the 9x squared, and I put everything in parentheses because that's going to tell me that I need to distribute if there's any extra terms. And I just distribute. 9 times 4 is 36. X squared times x is x cubed. And then that 9x squared times 3 is going to be 27x squared. That is our new function. And so that's f of x times g of x, and it's a different function. We could call it h of x or whatever. Okay, so the next one we're going to talk about division. Now this one's different in the sense that we have to be careful about dividing by 0. So with the statement that we currently have, we are going to have just the division of the two equations. But this is the correct equation. Nothing can simplify. But we also have to think about the bottom not equaling 0. And so what I do, if you notice, is I took the denominator and I created an equation and set it not equal to 0. If I solve this, it tells me that x cannot equal negative 3 over 4. And what I'm going to do is I'm going to restate my answer and tell the person who's looking at this what the domain is, or what the domain cannot be. And so if I have 9x squared over 4x plus 3, that's my new equation, but the semicolon says where x cannot equal negative 3/4. Negative 3/4 would make the denominator 0, which is undefined. So when you're dividing, you make sure that you put in this piece if there is what's called a domain restriction.